the third video in the Predicting Products series. In this segment, we will focus on combustion reactions. What is a combustion reaction? It's a chemical change in which an element or compound reacts with oxygen, often releasing energy in the form of heat and light. We're going to focus primarily on organic combustion reactions involving a hydrocarbon. In organic combustion reactions, the reactants always include some form of organic fuel, some hydrocarbon, reacting with oxygen, and the products always include carbon dioxide and water. Here's an example of a balanced combustion reaction. C8H18 is a large molecule. It exists in liquid form at room temperature. 2 moles of it are shown to react with 25 moles of oxygen gas, producing 16 moles of carbon dioxide and 18 moles of water vapor. When predicting the products for organic combustion reactions, carbon dioxide and water can always be listed as the products. Let's go over some helpful steps to balancing organic combustion reactions. Balance the carbon atoms first. Then balance the hydrogens next. Finally, make oxygen the last element to balance. In my experience, these steps are the most efficient way to balance organic combustion reactions. Following the sequence of steps that you just saw, we're going to go ahead and put a coefficient of 3 in front of the carbon dioxide to balance out the carbons. Then we will balance the hydrogens by placing a coefficient of 4 in front of the water. Now let's count up the oxygens. On the reactant side, you can see we have 2 oxygens. And on the product side, we have 3 times 2, 6 from carbon dioxide, and 4 times 1, 4 from water, giving us a total of 10 oxygens on the product side. To balance this reaction, all we need to do is put a 5 in front of the oxygen molecule on the reactant side. The sequence of coefficients for this balanced equation are 1, 5, 3, and 4. For problem number 2, we have C2H2 plus oxygen. The products will still be carbon dioxide and water. Let's balance the carbons by putting a coefficient of 2 in front of the carbon dioxide. You can see that the hydrogens are already balanced. So we have 2 oxygens on the reactant side. On the product side, we have 2 times 2, 4 from carbon dioxide and 1 from the water, giving us a total of 5 oxygens. To get 5 oxygens on the reactant side, we would need to put a coefficient of 2.5 in front of the oxygen molecule. Typically, we do not want to have a fractional coefficient. To eliminate the use of a fraction, what we can do is multiply the entire equation by 2. When we do that, our new coefficients end up being 2 in front of the C2H2, 2.5. If we double that, multiply it by 2, we get 5. Double the coefficient in front of the carbon dioxide, 2 times 2 gives us 4, and double the coefficient in front of the water. Currently there is no coefficient, so that means there's 1 water molecule. We're going to double that to 2. Our sequence of coefficients for this balanced equation then is 2, 5, 4, 2. Now it's your turn. Take a moment to predict the products for numbers 3 and 4 and write balanced equations. Pause the video and then check your work. Did you get these answers? In number 3, we have 8 oxygens from the carbon dioxide and 4 oxygens from the water, giving us a total of 12 oxygens on the product side. We only need a coefficient of 6 on the reactant side in front of the oxygen to balance this equation. No doubling of coefficients is required. In problem number 4, though, we end up with an odd number of oxygens before the doubling of the coefficients. I know that these coefficients have been doubled because there is a coefficient of 2 in front of the hydrocarbon, and because we have an odd number of oxygen molecules on the reactant side. Remember, when balancing combustion reactions, to follow the order of balancing carbon first, then hydrogen, then oxygen. Double the coefficients to eliminate the use of a fractional coefficient.